Hey guys, it's Mr. Bosher, and today we're going to go back to domain and range with graphs, but we're just going to look at a specific type of graph, okay? So you no longer have to worry about word problems. I know for a lot of people that one is a struggle and it's not very fun, and I don't blame you. But now we can go back to graphs and ask ourselves like, hey, let's just go to the left, let's go to the right, let's go up, let's go down, and we just have to plug in the pieces, okay? So we're back to that. So we get more practice on that. And the types of graphs we're going to look at today are going to be graphs that have sort of this, hello? Oh, there we go. These graphs that have these U-shapes to them, okay? We'll learn later in the year that these are called quadratic functions or parabolas. But we're not going to get into like details right now, because right now our main goal is, hey, can we get more and more comfortable with domain and range, okay? But just some background is that it's called a quadratic function. All right? And that's just going to be what we focus on today, on like how do we handle those. So, typical steps, right? We're back to domain and range. If I start with domain, first thing we're going to ask ourselves is, what kind of values does it use? It's going to use x values. So we're going to write x. Okay. Then I got to ask ourselves, which directions do x values go? Well, they go left and they go right. So if I follow my graph here to the left, well, I run into an arrow. So do I have a stopping point on the left? Nope. Absolutely not. Okay. If I go to the right, do I have a stopping point on the right? No. I get another arrow. So if you remember from a while back, what happens when both directions don't have a stopping point? Well, we say that we use every single number, so this would be all real numbers. Okay, so our domain in this question will be all reals. There we go. All right, simple enough. Now, we're going to look at the range. First question you're going to ask yourself is, well, what kind of values do I use for range? Well, we use y values. And then we have to say, okay, I know I use y values, but what directions do the y values go? Well, they go up and they go down. So I'm going to go from the bottom, I'll just say bottom to the top. Okay? So I have to look now and say, okay, well, do I have a bottom or top? Because for the domains, I didn't have any stopping points, right? So now I got to think, well, maybe I want to have stopping points for the y values. Okay? So let's see. Do I have a bottom value? So if I take any starting place, so let's say like maybe I start over here, and I go downwards on the graph, do I eventually hit a spot where it's the actual bottom? I do. I hit that coordinate point right there, okay? And that coordinate point seems to be -3, -7, right? And I want y values, so my bottom value will be -7. So let's go ahead and replace that with bottom. And the reason that I wanted to show you an example of these types of graphs is because I'm pretty sure so far the examples I've shown you and your Alex assignments have marked the points. Okay, so if I sort of take this away real quick, notice that there's not a coordinate point at that bottom point right there, right? And it's just a line. I'm pretty sure this is the first time we've seen that. But it doesn't matter, right? Because a line is basically just a bunch of points. I could say this is a point, this is a point, this is a point, and so on. So as long as it's on the line that is used for our graph, then that would count as a point. Okay, so we just say, well, where's like the bottom part of this line of this graph? Well, it'd be right here, and we can write the point in ourselves. Okay, so that's one new thing that comes with this assignment, is that they're not always going to mark a coordinate point for you. Okay, but you still ask yourself the same questions, and you take the thing that makes the most sense. We say, well, what's the bottom value? Well, obviously, it's going to be that sort of like dip, right, in our valley here. So I just had to say, well, what's that coordinate point? And we said that it's -3, -7, and I want the -7. All right. Now the other question is, well, is that coordinate point filled in or is it open, right? Should I be filling it in or should I write it as an open? Well, notice that the line is bold. If the line was sort of dashed instead, then we would say we use an open point. But when we have a bold line like they show us here, then we say the point is filled in. And whenever we have a point that's filled in, what do I do with my symbols? I go to my symbols and I say that's going to need an equals to. Okay? So those are the new things with the graph side. Okay? So that's one of the new things I wanted to show you. They don't mark the coordinate point, and do you fill in the point or do you leave it open? Well, if they use bold lines, then you leave it, or then you close it. If it was dashed lines, then that's how we interpret an open point. Okay? So in this scenario, they used a bold line, so we know that it's filled in, and the coordinate point would be right there. And it's -7 is the y value. That's my bottom. Well, I'm not done, right? Now I have to look and say, well, where's the top? Well, the top, if I move upwards, I run into an arrow over here. And I say, okay, that's all right. Maybe the other side has a stopping point. And I go over there. Oh, it also doesn't have a stopping point. So if I look at this graph, I always have a way to keep going up, right? Even if one of these sides did stop. Let's say I stopped on this side. Yeah, I stopped over there, but over here, I still go upwards. So did I really get stopped by this point? Not really, because I can keep going further and further up, right? Because I have an arrow. So because we notice we have the arrows pointing upwards, that means we're going to go forever. So do we have a top stopping point? Absolutely not. And we would just erase that part of the problem. And we would say our range is y is greater than or equal to -7. Because if I look on my graph, every single coordinate point will have a y value that is greater than or equal to -7. Right? And that's the basic idea with the graphs. So let's do one more, get comfortable with that, and then I'll show you what the second thing I need to show you is for today. All right, on to question 4, or at least 4 from this worksheet. So we're going to start with domain. What's the question we ask ourselves? Well, what values do I use for a domain? We use x values. Cool. What directions do the x values go? They go left and they go right. So let's see. If I go to the left, I move to the left on my graph, I hit an arrow. If I move to the right on my graph, I hit an arrow again. So it seems like I have no stopping point on the left and I have no stopping point on the right. So I'm going to hit every single number, right? I go forever to the left and I go forever to the right. So there is no stopping point. So what do we write when that happens? We say that it's all real numbers. I'm just going to say all reals because that's what I can fit. Okay? All real numbers. Hopefully you remember that from one of the previous videos I did. And if you didn't, hopefully you're starting to get the hang of it right now. And maybe you've already seen a pattern that happens with these quadratic functions and these arrows, right? All right, that's domain. Now we're on to the range, which is y values. I kind of skipped that question, but we know the process by now. You say, what is the range? What kind of values is it? It is y. What directions can I move with the y values? Well, I can move up and down. So I'm going to go from the bottom to the top. All right. Let's see. If I try to find a bottom stopping point and I move downwards, it looks like I'm going to run into some arrows. So do I have a stopping point on the bottom of this graph, right? If I move downwards, do I have a stopping point? I do not, right? I run into arrows, which means forever. So I can already go ahead and say, well, I'm not going to have a bottom part to this. I can get rid of that. But will I have a top part? Well, let's do the same thing, but move upwards. If I follow my graph upwards, it seems like we stop right here. It's sort of the peak of this hill. And what's the coordinate point there? Let's see. It looks like it's 2, 3. And this is range. So remember, we want y values. So that would be 3. So we can go ahead and say, well, the top value would be 3. And all we need to ask ourselves now is, would it be equal to or not equal to? Well, we look at what kind of line we have. We have a bold line going through here. And whenever they use a bold line and you have to draw your own coordinate point, that would be a filled in coordinate point, right? They did not use dashed and they didn't draw it for you. So the assumption is that it's filled in, okay? So because it's filled in, we say, well, a filled in point would mean that I have to put equals to. We learned that at the very beginning. All right, so it's rewrite that as y is less than or equal to 3. And there you go. Okay, so when I give you a graph of a quadratic function, which is basically just this U shape or upside down U shape, that's the basic idea. How is it different from what we were doing before? Well, it's mainly that they don't mark the coordinate points for you as hints. Okay, some of your questions on tests in the future are not always going to mark the points that may be used for domain and range. You have to sometimes mark those yourself. Okay, so that's like the new challenge with this assignment. All right. Second part of the assignment is, what if you don't get a graph? But don't worry, it's not a word problem. Okay, it's still going to be pretty easy. Basically, what are you going to do when I give you an equation? Okay? And the notes that I would have handed out if I was there, we're going to give you all these steps of like, hey, here's how you do it by hand. Which is cool, but who cares? Okay? Because we live in the age where we get to use Desmos. And why in the world would you do this by hand if you have the ability to just use a calculator to show you the picture? And that's our best strategy, right? We should be pretty comfortable by now to do domain and range with a graph. So if a calculator can just give me a graph, why would I use these steps, right? So that's what we're going to do. Our steps for when they give you an equation are just going to be plug in Desmos. That's simple. Okay? So we're going to go and plug this into Desmos and see what does it look like, and then how would we go from there to find domain and range. Okay? And then I'm going to do these two examples, and then that'll be it. All right? And you're just going to practice more domain and range. So, let's see. G of x equals, let's go to Desmos. We had G of x equals, I think it was 5x squared was the start of it. Yeah, 5x squared plus 10x plus 8 plus 10x plus 8. And you notice we get a pretty similar looking graph to what we did before. Okay? So if I take a look at this graph and I try to like zoom out and see if it ever ends, you might notice that, well, on Desmos, graphs don't end. I can keep going and 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 keep going. It doesn't end, right? So just know that on Desmos, if you see that the graph is continuing in direction, it's gonna just keep going in that direction, all right? You don't spend your time sitting there trying to find an end to it. So we have our graph, and now we need to ask ourselves, well, what's the domain and what's the range, right? The questions that we've been doing. So let me get to where I can write on this. All right. And let's start with, we'll do domain. We always start with domain. Cool. Well, we have domain. And first thing we ask ourselves every time with domain is, well, what kind of values do we use for domain? We're going to use x values. All right. And x values can move which directions? Well, they can move left and they can move right. Well, we've seen other examples where we have this shape, and when I move to the left, let me redraw that. When I move to the left, do we ever end? No, right? You just saw me zoom out, and the lines won't end on Desmos. So we don't have a stopping point on the left, and if I go to the right, do we ever end? Nope. As long as I move to the right, I will keep following that line on Desmos. So, when I don't have a stopping point on the left and I don't have a stopping point on the right, what am I going to put for my domain? I have to say that we hit every number, or we say all reals, right? That's the usual way that we phrase that. All reals are all real numbers, or yeah, that basically that's it, right? All reals. Okay. Then we got to find our range. Our range uses what kind of values? We know that the range is for the y values. Then we say, okay, well, y values go which directions? Well, they're going to go up and down. So we're going to go from the bottom to the top. Okay? So if I look and try to find a bottom point to this graph, and I head downwards, oh, you know what? Let me use a different color so it doesn't blend. Let's use green. There we go. If I move downwards, we see that we hit this coordinate point here, okay? And you notice that I selected that point before I moved to this screen. So when you go to Desmos and you find your bottom point, you can click on it, and it will highlight it for you so that you can get the actual coordinate point for it. That'll make your life a lot easier, all right? And we say, well, what value do I want for what I'm looking for right now? So we say, well, I'm looking for range, and I went down and I found this point. And so if I'm looking for range, I care about y values, so I would want the 3. Okay, so my bottom value should be 3. Okay, then we ask ourselves, okay, well, do I put the equals to or not? Well, did Desmos use a bold line or a dashed line? It used a bold line, right? So that coordinate point is filled in. And you'll notice, too, that if I erase everything I wrote, once you select the point, it's also filled in, right? So you can say, well, the point that Desmos put on there is also filled in. So a filled in point means equals to. All right, easy enough. And then all we have to ask ourselves now is, well, is there a top? So if I move upwards, again, I'll go to green so I don't overlap. As I move up the graph, it seems like it just goes forever, right? Because if I were to zoom out and go and go and go like I showed you earlier, it never stops. So do we have a top? Nope. And there we go. Just like you did on the ones that gave you a graph, just now your graph is on Desmos because you had to type it in yourself. That simple. Okay? And that's basically it. And honestly, at this point, I think that you guys can probably go from here. If you can understand the two examples I did with graphs already, then all this is hey, plug it into Desmos, right? And just get used to working on Desmos. And just as a reminder, like, what do we plug into Desmos? Exactly what they tell you. Okay, exactly as the problem appears. So right here, I just wrote that equation. If they would have said y equals, like they did here, then I would have typed y equals all of that, and it should work. If they use f of x equals, I will just put f of x equals all that, and it will work. Okay? And it will give you a shape that either is an upside down U, or it will give you a shape that's a, oops, that goes like this. Okay? So if you ever get a question that just gives you the equation, and it still wants the domain and the range, let's see, oh yeah, there we go, the domain and the range, then all you do is that you plug it into Desmos, and then you act like it's one of these up here, right? You have the graph. Okay? So, other than that, I think that's it for today. Just try to get more used to, hey, I might have to write my own coordinate points, okay? Because sometimes they won't mark them. And get used to, if they give you an equation, I gotta just take that to Desmos to make my life easy, right? Because you don't want to use all these steps right here. This is going to be way harder than just going to Desmos and doing the graph method like we've been using. All right? So other than that, if you need any help, send me a Canvas message. I can try to explain it a different way. But yeah, you can get started on the assignment. Good luck, and have a great day.